Download this code from codegive.com, link in the description below. Branch by abstraction, a deep dive into decoupling change. Branch by abstraction, popularized by Paul Hammant in his 2020 Agile India talk, which, while not formally published, has been widely discussed and practiced, is a powerful refactoring technique that allows you to introduce significant changes to a code base without creating long-lived feature branches and the associated integration headaches. It decouples the introduction of a new implementation from the removal of the old one, minimizing risk and allowing for incremental adoption. This tutorial will provide a comprehensive understanding of branch by abstraction, covering 1. The problem, why feature branches often fail. 2. The core principle, decouple change and release. 3. The technique, branch by abstraction explained. 4. Steps for implementing branch by abstraction. 5. Code example, migrating a database access layer. 6. Benefits and drawbacks. 7. When to use branch by abstraction. 8. Tools and techniques to support branch by abstraction. 9. Common mistakes to avoid. 10. Alternatives and variations. 11. Conclusion. 1. The problem, why feature branches often fail. Traditional feature branching involves creating a separate branch for each new feature or significant refactoring effort. While seemingly intuitive, this approach can lead to numerous problems, especially in long-lived branches. Merging long-lived branches can be incredibly complex, time-consuming, and error-prone. Conflicts are common, requiring developers to spend significant time resolving them instead of building features. Code drift. The code in the feature branch diverges from the main branch over time, leading to integration issues when the branch is finally merged. Delayed integration. Integration is postponed until the feature is complete, which can be a long and unpredictable process. This delays feedback and increases the risk of major integration problems. Reduced collaboration. Developers working on different branches may not be aware of each other's changes, leading to duplicated effort and potential conflicts. Deployment risk. Deploying a large feature branch at once can be risky, as any problems introduced by the new code will affect a significant portion of the application. 2. The core principle, decouple change and release. Branch by abstraction addresses these problems by decoupling the introduction of a new implementation from the removal of the old one. Instead of working on a separate branch with the new implementation, we introduce an abstraction layer that allows us to switch between the old and new implementations at runtime. This allows for continuous integration and controlled rollout of new features. The key ideas are: incremental change. Introduce changes in small, manageable steps. Continuous integration. Keep integrating with the main branch frequently. Controlled rollout. Gradually expose the new implementation to users, monitoring for issues and allowing for easy rollback. 3. The technique, branch by abstraction explained. Branch by abstraction is a refactoring pattern that involves the following steps. 1. Create an abstraction. Introduce an interface or abstract class that defines the common functionality that both the old and new implementations will provide. 2. Implement the new implementation. Create a new class that implements the abstraction, providing the new functionality. 3. Create a feature toggle, or equivalent. Implement a mechanism, example feature flag, configuration setting, to switch between the old and new implementations at runtime. This allows you to control which code is executed. 4. Gradually switch over. Configure the feature toggle to direct traffic to the new implementation for a small subset of users or requests. Monitor the new implementation for errors or performance issues. 5. Increase adoption * gradually increase the percentage of traffic routed to the new implementation, while monitoring the system. 6. Remove the old implementation * once you are confident that the new implementation is stable and performs well, remove the old implementation and the feature toggle. 7. Clean up the abstraction, optional if the abstraction layer is no longer necessary, remove it. However, consider leaving it in place if it provides value as an API or provides future extensibility. 4. Steps for implementing branch by abstraction. Let's break down the steps in more detail. Step 1, identify the code to change. Select the area of code you want to refactor or replace. This could be a database access layer, a business logic component, or any other well-defined module. Understand the current dependencies on this code. Step 2, define the abstraction, interface/abstract class. Create an interface or abstract class that defines the contract for the functionality provided by both the old and new implementations. This abstraction should be focused and well-defined, representing the essential operations that clients need. Don't try to anticipate all future needs, start with what's currently necessary. Use clear and meaningful names for the abstraction and its methods. Step 3, implement the new code. Write the new implementation of the abstraction, providing the desired functionality or improvements. This implementation should be independent of the old code. Step 4, introduce the abstraction, replace direct dependencies. Refactor the code that currently depends on the old implementation to depend on the abstraction instead. This is a crucial step. Use dependency injection or other techniques to inject the implementation into the client code. This decoupling is what enables the runtime switching. Step 5, implement the feature toggle. Add a mechanism, feature flag, configuration setting, environment variable, to control which implementation is used at runtime. A simple conditional statement, example if, feature toggle, use new implementation, else use old implementation, is the core of this. Centralize the feature toggle logic in a configuration file or a feature toggle service for easy management and updates. Step 6, test, deploy, and monitor. Thoroughly test both implementations, ensuring they meet the required functionality and performance criteria. Deploy the code with both implementations and the feature toggle in place. Monitor the system closely for any errors or performance issues, especially after the switch to the new implementation. Step 7, gradual rollout. Start by enabling the new implementation for a small subset of users or requests. This is often called a canary release. Monitor the system metrics, error rates, performance, resource usage, to ensure that the new implementation is behaving as expected. If any problems are detected, immediately revert to the old implementation by disabling the feature toggle. Step 8, incremental adoption. Gradually increase the percentage of traffic routed to the new implementation. Continue monitoring the system metrics closely. Step 9, remove the old code. Once you are confident that the new implementation is stable and performs well, remove the old implementation and the feature toggle logic. Consider keeping the abstraction layer if it adds value as a clear API for future development. Step 10, clean up. Remove any temporary code or configuration settings related to the feature toggle. 5. Code example, migrating a database access layer, Java. Let's illustrate branch by abstraction with a Java example. Suppose we want to migrate our database access layer from using JDBC directly to using a more modern ORM like Hibernate. Initial code, old implementation, JDBC. Step 1 and 2, create the abstraction, interface. Step 3, implement the new code, Hibernate implementation. Important asterisk: ensure you have Hibernate set up and configured, including hibernate.cfg.xml, correctly for this to work. The user class needs to be an entity mapped to the database. Step 4, introduce the abstraction, replace direct dependencies. Assume you have a user service that uses the user DAO. You'll need to modify it to use the iUser DAO interface and inject the correct implementation. Step 5, implement the feature toggle. We'll use a simple Boolean flag defined in a configuration file or system property. For simplicity, let's assume it's a system property. Now, in your main method or dependency injection container, you would use the DAO factory to get the correct DAO implementation. Steps 6, 7, 8, and 9, test, deploy, monitor, gradual rollout, remove old code. Test write unit tests for both user DAO JDBC and user DAO Hibernate to ensure they both work correctly. Test the user service with both implementations to ensure the abstraction works. Deploy the application with the use Hibernate DAO system property set to false initially, using JDBC. Monitor the application's performance and error logs. Gradual rollout once you're comfortable, set use Hibernate DAO to true for a small group of users or a test environment. Monitor closely. Incremental adoption increase the scope of users using Hibernate. Remove old code once you're confident Hibernate is stable and performing well, remove the user DAO JDBC class and the use Hibernate DAO feature toggle from the DAO factory. 6. Benefits and drawbacks. Benefits reduced merge conflicts changes are integrated frequently into the main branch, minimizing merge conflicts. Continuous integration supports continuous integration and delivery practices. Lower risk gradual rollout allows for early detection of problems and easy rollback. Improved collaboration developers can work on different parts of the system without stepping on each other's toes. Faster feedback new features can be released to users quickly for feedback. Independent deployment changes are deployed independent of complete feature delivery. Facilitates refactoring safely refactor large portions of the code base. Drawbacks increased complexity introduces an abstraction layer and feature toggle logic, which can add complexity to the code base. Testing overhead requires testing both the old and new implementations. Maintenance overhead requires managing the feature toggle and potentially the abstraction layer. Performance considerations the feature toggle logic can introduce a small performance overhead. Abstraction layer design requires careful design of the abstraction layer to ensure it is flexible and extensible. 7. When to use branch by abstraction. Branch by abstraction is particularly useful in the following situations. Large-scale refactoring when refactoring a large and complex code base. Replacing legacy systems when replacing a legacy system with a new one. Migrating to new technologies when migrating to a new database, framework, or programming language. Introducing new features when introducing complex new features that require significant code changes. *A/B testing * when comparing different implementations of a feature to determine which one performs best. *Cloud migration * migrating from an on-premises environment to the cloud. 8. Tools and techniques to support branch by abstraction. Feature toggle libraries libraries like toggles, Java, FeatureFlow, LaunchDarkly, and others provide a framework for managing feature toggles. These libraries often offer features like centralized configuration, targeting users based on attributes, auditing and logging, A/B testing support, dependency injection dependency injection frameworks, Spring, Goose, make it easier to inject the appropriate implementation of the abstraction. Configuration management tools tools like Console, Act, and Kubernetes config maps can be used to manage feature toggle configuration. Monitoring tools tools like Prometheus, Grafana, and Datadog are essential for monitoring the system during the rollout process. Automated testing comprehensive automated testing, unit tests, integration tests, end-to-end tests, is crucial for ensuring the stability of both implementations. CI/CD pipelines automated CI/CD pipelines streamline the deployment and rollback process. Design patterns patterns like strategy, factory, and abstract factory can be helpful in designing the abstraction layer and managing the different implementations. 9. Common mistakes to avoid. Creating overly complex abstractions start with a simple abstraction and add complexity only as needed. Leaking implementation details the abstraction should hide the implementation details of both the old and new code. Keeping feature toggles around too long remove the feature toggle and the old code once the new implementation is stable. Otherwise, you'll accumulate technical debt. Insufficient testing thoroughly test both implementations to ensure they are working correctly. Ignoring monitoring monitor the system closely during the rollout process to detect any problems. Poorly designed feature toggle logic centralize feature toggle logic and make it easy to manage and update. Hard-coded feature toggles avoid hard-coding feature toggles in the code. Use configuration files or a feature toggle service. Neglecting rollback procedures ensure you have a clear and tested rollback procedure in case problems are detected during the rollout. 10. Alternatives and variations. Strangler fig pattern this pattern, closely related to branch by abstraction, involves gradually replacing a legacy system with a new one by placing the new system behind an API gateway. Requests are progressively routed to the new system. Dark launching deploying a new feature to production but not making it visible to users. This allows you to test the new feature in a real-world environment without affecting users. This is often combined with branch by abstraction. Canary release releasing a new version of the software to a small subset of users. Blue/green deployment running two identical environments, blue and green, with only one environment serving live traffic at a time. When deploying a new version, you deploy it to the inactive environment, test it, and then switch the traffic to the new environment. 11. Conclusion. Branch by abstraction is a valuable technique for managing complex code changes and reducing the risks associated with feature branching. By decoupling the introduction of new code from the removal of old code, it enables continuous integration, gradual rollout, and faster feedback loops. While it does introduce some complexity, the benefits of reduced merge conflicts, lower risk, and improved collaboration often outweigh the drawbacks. When implemented correctly, Branch by abstraction can significantly improve the speed and stability of your software development process. Remember to start with a simple abstraction, test thoroughly, and monitor closely during the rollout process. Don't be afraid to experiment and adapt the technique to your specific needs and context.